Yeah, the commercial applications of 4D Gaussian splatting in specifically the L&D sector, but overall as well. So yeah, we're based in central London. The one side is our services side. We create tailored captures towards data collection, streamlined data sets, and so on. And we've done this a lot for the sort of visual effects and film industry and TV industry. And on the product side, we basically focus on the L&D sector. That is because the 4 founders, including myself, have quite a large combined experience of basically working in the sector and understanding what some of the technical challenges are. Okay, we now have 4D Gaussian splatting. It's a great way of reconstructing. It's a great way of visualizing this content. Let's see how we can apply this. So what are some of the boundaries of L&D, just to understand where we're actually coming from? So by L&D, this really kind of refers to a wide sector of generally digital training solutions or digital learning. So that's basically where the critical gap is, how people naturally learn through observation and how training is delivered, which is this sort of 2D views. So what do we mean by spatial learning? When learners observe an expert performing a task, they naturally want to move around it and see it from different angles. And you gain some cognitive advantages of doing this in-person observation without these limitations by using our technology. So big question, of course, is what is 4D Gaussian splatting? Gaussian splatting itself is a rendering technique that represents objects as millions of tiny little 3D points of light called splats, and they kind of instantly create these photorealistic imagery. So the result is basically a smooth natural motion, real performances, real presence, and playable in VR. So how does it work? What does the pipeline look like? So we have our own synchronized camera array with 78 cameras at a very high sort of quality, capture 24 megapixels per camera, so about 2 gigapixels per 3D frame, which is a lot of data. We then compress the data, and then we reconstruct it. We have to do an initial compression stage just because we process the actual 4D Gaussians in the cloud, and then eventually it is optimized for VR outputs. This is, again, compressing the splats themselves, the 3D sequences further. For the real-time rendering, it's something that is the limitation, but also the sort of welcome thing that comes from Gaussian splatting. Due to the models being relatively light, you can real-time render them live, and I will demonstrate that. This is a general idea of how people interact with these 4D scenes. So this is a 4D recording of a junior doctor, and we basically filmed how does he do a knee examination, and how does a learner who's potentially learning this content observe it, and how do they get the perfect viewport, and how do they get the angle that they're trying to attain. Or technically challenging to reconstruct things, such as this bicycle demo. I personally cycle a lot, and I always hated the way that in a 2D video, it's quite challenging to see how to sort of work on a bicycle. You have to set up the camera in a certain way, and you're relying on the person to be very skilled at that. But this 4D Gaussian technology allows me to view it from the perspective that I want. And even, as you can see, the spokes and the wheel and everything is reconstructed to a quality that it's quite impressive, at least for us. One of the biggest challenges is capturing more than one person in a small space. In this specific example, actually, it's not our only demo with 2 people. We have one demo with 2 people fighting, which is actually a better example because they get quite close to each other. But as you can see, despite occlusions from certain angles, you don't have any sort of infill, and you don't have any sort of problems with separation. How garments move in time, over time, and how transparency works with different materials. And Gaussian splatting is particularly good at representing that. So as I said, we are mainly interested in the educational application of this technology, because the first MVP that we are developing at the moment, and something that we sort of have as a gold standard target, is medical training, because they have a very high adoption of VR training already. First, this technology, it's something that it's under development still, because we don't have 4D Gaussian avatars yet, but which would make that kind of content much better. But seeing how the research is going and seeing how people are developing in that sector, I'm sure it will not be too long. About our services. As I said, we're Central London, and we're capable of producing datasets of pretty high quality. In about 30 minutes, we can capture something in the region of 300 terabytes of data, which is due to like higher frame rates and extremely high resolution, as I mentioned. And then we actually reduce that data down to around 2% of the original size while retaining that quality to be able to handle this. We wanted to make this technology accessible as quickly as possible to the VFX industry. The VFX industry is very used to relighting and very used to having full control over 3D assets and 4D assets. And then, yeah, about spatial sound and audio. High-grade audio is required for high-grade visuals.